Yes, the zombies are back now and they're ready to test. They'll take that development code and tear it from your chest. Refactor your mind, take the test from red to green. All with an undead beam.
You're watching Rails Testing for Zombies. I'm Nathaniel Bibler, and this is Level 5, Integration Testing. Greg just walked you through the first few levels, talking about unit testing and isolation testing, and the problem there is that when you're testing little pieces, it's hard to tell if the whole thing works. That's where integration testing comes in. So let's get started. Integration testing tests your full application stack. Now in a Rails context, that generally means from the rack level down into Rails and then back out. It could be said that it tests from the outside in. It could also be called black box testing. And it's basically testing what the end user is going to see and how your application is going to respond. Now it should be noted here that integration tests don't actually spin up your entire server stack. So if you need to test something like Nginx or a caching layer or something else, this isn't quite the place to do that. So if you've ever done any Rails development in the past or ever used the scaffold in the past, you might have noticed that Rails will actually generate controller and view tests for you automatically, just like they do with the model tests. Why aren't we talking about the controller and view tests here? Why did we jump straight from unit test into integration test? And the reasoning there is that views and controllers really shouldn't have logic to them. And in the case that maybe they do, those should be isolated tests which aren't considered integration tests. Integration tests should ultimately completely have you covered because they test your full stack. They're going to touch the view, the controller, your business objects, and back out. There are some people out there that do test their full application at every level, isolating the view, controller, model, and then having a full integration stack. At NV Labs, we found that we can pretty much get by with testing our models in isolation and then having a full integration suite on top of it. Now let's talk about some of the things that Rails gives you to help you with your integration tests. First of all, it gives you web browser-ish like queries to be able to actually call into your application, acting like the end user's web browser. You'll see that these are really low-level calls, such as get, post, put, and delete. These aren't clicking on links, these aren't filling out a form, right? These are very, very low level, and what they do is they send a request and they get back a response, and at that point your tests are against those particular responses. So because these are very low-level requests, it's not going to do things like follow redirects for you. So Rails also gives you some other helpers like follow redirect, where it will look to see if the last response was a redirect response, follow that redirect, make a GET request to whatever the location is, and let you continue with your testing. I should also note here that if you call follow redirect or any of the other redirect helpers that Rails provides, and the last response wasn't a redirect, it's going to throw an exception. So now that we've seen how to act like a web browser and kind of make those external calls into your application, we need to come back again to assertions. We saw that Ruby gives you some level of assertions. We saw that Rails adds some extra assertions to that at the model and unit level. But at the integration level, Rails gives you even more custom assertions, such as assert response. And again, this is going to look at your last response coming in, and assert response is going to check the status code of that response. So in this case, we're checking that the last response was a success, which equates to 200. So you could either use the success symbol, or you could use the numeric 200 and get the same result. Rails also provides you a few other helpers for the assert response, such as redirect, missing, or error, where it'll check for a 3 anything response, a 404 in the case of missing, or a 5 anything response for a server error. Rails also gives you access to all of the rack-defined symbols that represent status codes, such as moved permanently with HTTP 301 or accepted with 202. So along with assert response, Rails also gives us assert redirected to. What that's going to do is check that the last response is a redirect, and it's going to test that the location header in that response is what we expected. In theory, that the end user's web browser is going to go where we think it's going to go. It also gives you assert tag, where you can test against the contents of the DOM returned. So what it's going to do is look at the last response, look at the body, make sure that it's an HTML document, and then you can basically define what elements you're looking for. So in this case, maybe we're looking for an anchor tag that has an href to the root URL. We could also conversely say it does not have a tag. So we could say it doesn't have a div with an ID of zombie. Rails also gives us assert select, where unlike the tag assertions where we talk about DOM elements like a and div, we can use a CSS selector, and it actually takes an optional parameter after that where we can even specify the content that we're looking for in that particular element. So how do we actually create an integration test? Well, Rails actually has an integration test generator that can be used like this. You can say Rails generate integration test and then give it a name. That name can be anything you want. It doesn't have to match a model that exists. It doesn't have to match anything. In this case, we're saying zombies, so that's going to create an integration test called zombies test, and inside it, it's going to make a new class, zombies test. When it gets run, you're going to see it creates a test integration zombies test file. At the top, you're going to see the require test helper, which is what we saw in the models. And then you're going to see class zombies test. But in this case, you're going to see that it's inheriting from action dispatch integration test, whereas before it was coming from active support test case. And then you're also going to see fixtures all, which is a call to tell Rails to load all of the fixtures. But again, Rails isn't actually going to generate any tests for us. They're just going to put in a stub to tell us where they want us to put the tests, and it's up to us to define them. So let's write our first integration test. To do so, we're probably going to have to know a little bit about the response coming back because we want to know what we're going to say is happening. So over here, you can see what the response might look like for the zombie show page. And in this case, what's important is that we're showing a page for Ash, and we're dictating that by saying in the header, the zombie's name, in this case Ash, is present. So how do we test for something like that? Back in our zombies test integration test file, we're going to add a new test that says anyone can view the zombie information. And what we're going to do here is load a zombie from the fixture. We're going to get the zombie URL for that particular zombie. And then we're going to assert that the response was successful. This will give us an early indication if we have a typo on the view page, a typo in the controller, or some other blatant issue here where we would see a 500 response. Next, we're going to call assert select. We're going to look for the H1 element, and we're going to test that the contents of it are Ash in this case, which is what we're looking for. I should note here that unlike earlier when Greg taught us that you should generally have one assertion per test, you're seeing that we're doing two. The reason for that is because now that we're at integration test, it takes a little bit longer to run down the entire stack and make the fake request and check the response. So it's a little bit of a trade-off between time to run the test versus what we're testing. I should also note that because we have two assertions in one test, if the first assertion fails, we're not going to have any clue as to whether or not the second assertion passes or fails. That's the benefit of splitting it into separate tests. Now that we've seen what Rails gives us to aid with integration testing, you've probably noticed that there could be some issues with it. You know, how do you navigate multiple pages? Do you make 30 GET requests? How do you exercise forms and buttons? We haven't even talked about that yet. And at the end of the day, wouldn't it be better if it acted more like a web browser, where it followed redirects automatically and kind of handled some of those things for us? So I want to introduce you to Capybara, which is going to be another external gem. It was written by Jonas Nicholas, and it simulates user activity and the user's browser. And with it, you could do things like visit login path. So this is different from the get, put, post that we saw earlier. You can say within a particular element on the page, we would like to fill in the login field with a value. We'd like to fill in the password with another value. Maybe we'd like to check a remember me button, and we'd like to click on a login button. And unlike the original Rails integration tests, it acts like the browser, so redirects are automatically followed. So, how do we install Capybara? Well, just like with the other gems, we're going to open our gem file. Inside of the test group, we're going to say gem Capybara. We're going to rebundle to make sure it gets installed. And then we're going to open our test helper. In our test helper, at the top, we're going to add a requirement that says require Capybara Rails. That's going to tell Capybara to place whatever hooks are necessary to tie into the integration test suite that Rails already provides so that it knows where things are at. We're also going to open up the action dispatch integration test class that we saw earlier being inherited in our test, and we're now going to include the Capybara DSL module. We're also going to define a teardown at this level that instructs Capybara to reset its sessions, because again, it acts like a web browser, so it actually has a session, it has cookies, it has a history. And then we're also going to tell Capybara to use the default driver. We're not going to touch much on drivers, but what they allow you to do is things like exercise end-user JavaScript, access third-party websites, etc. There's multiple drivers out there, but for the purposes of this course, the default is perfectly acceptable. So we touched a little bit on some of the methods that Capybara provides to allow us to act like an end user and their web browser. Let's look into a little bit more detail at what they might be. You can see here we get click link, click button, or click on. So click link looks for an anchor tag with an href, click button looks for a button element, or click on looks for either of the two. In all cases, you can provide a parameter to the methods that have either text, which is the text the end user would see on the page, or the element's ID. Next, Capybara gives us a bunch of form interaction methods, such as fill in element with value, choose a radio button, check a checkbox, uncheck a checkbox, attach a file, or select a particular element from an option group. These fields can be looked up either from their form label, from their element name, or from the element ID. And finally, Capybara gives us a couple of helper methods, if you will, called current path and current URL. Because Capybara acts like a web browser, it's automatically following redirects, so sometimes it's nice to know exactly where we are because it might not be the last place that we requested. Let's look at the integration test that we wrote earlier and see how we might write it using Capybara. So in this case, we've got anyone can view zombie information. We're still loading our zombie from the fixtures. In this case, we're now going to visit instead of get the zombie URL. We're going to assert that we're on the page that we expect to be on. And we could use another Capybara method called within to say within h1, which will isolate where it looks on the page, to say that within that h1, we want to make sure that the zombie's name is present using the hasContent method. So what is this hasContent method? Well, just like everything else, hasContent is a method provided by Capybara to help us with our testing. In this case, hasContent takes a parameter, which is text, that we're trying to check to make sure is on the page. It's going to return true or false. And it's going to make sure that it's visible text on the page as well. Along with hasContent, there's hasNoContent. And since this is such a widely scoped thing to say like ash should be somewhere on the page, a lot of times it's nice to be able to constrain that using the within call. Along with hasContent, Capybara provides us with hasSelector. In this case, rather than giving it text, we can give it a CSS selector, and it can find an element on the page by that selector. So here we have the ID of zombie1 with an h1. It also has hasNoSelector. And you can use hasSelector with optional parameters like text to say it should have a zombie1 element that has an h1, and that h1 should have the text ash. Or you could say this page has zombie class elements. There should be 5 of them on the page, and all 5 should be visible. Along with hasContent and hasSelector, we get something like hasLink, hasField, where we check for a hyperlink, or we check for a form field. We also have even lower level things like hasCSS or hasXPath. If that's what you need, it's also there for you. So getting back to our tests with Capybara, we should talk about how Capybara tries to enforce testing behavior. Because we're acting like the end user, we want to test as if we were the end user, right? So getting back to our earlier test, we might load a zombie from the fixture file, load a tweet for that zombie from the fixture file, and browse to the home page using visit root URL. We could say, well, within a element with the ID of tweet1, for example, we want to make sure that there is a link with the zombie's name on it. And when we click on that link, we want to make sure that we end up on the zombie's page. So rather than looking for elements and text on the page that says I should have an href that does this, we're now saying this is what we did and this is where we are. Finally, let's write a more interesting test and maybe test something like a sign-up form. So here, we'll make a test called should create a new zombie. We're going to visit the root URL. We're going to click on the link to sign up. On that page, maybe there's a form. We're going to say fill in name with brains. We're going to say fill in graveyard with brains. We're going to click the sign up button, and we are going to now assert that we are on the zombie's page. So the idea is if it created the zombie and redirected us to the page, it must have been successful. Now for integration tests, you'll find that signing up or signing in are something that probably happens a lot. Just like in the first group of unit test levels where we talk about refactoring your code and refactoring your tests, Since this is something that's going to be used a lot, we might want to extract some of that activity into a helper method, such as sign up as. And what that will do is allow us to rewrite our test once again to just say, visit the root URL, sign up as brains, assert that I have content, welcome brains in this case. So that's it. I know it was a lot of content. Capybara and integration tests are a little bit of a change of thinking against what we've been doing up to this point. Up ahead are some challenges for you to see how much you've learned, writing your tests, testing your assertions, and seeing how well you do. Again, if you need to look back at the video, go ahead and do that. Good luck.